Equations have one solution, one number that makes the equation true. Inequalities have an infinite number of numbers that will make the inequality true, which is why we don't check them. When you switch the sides of an equation, you don't really have to worry about anything. You can just switch the left and right sides. But in inequalities, when you switch the sides, you have to change the direction of the inequality symbol. The last one, which is the most significant difference, is the glitch, which we will go over here today. Again, the glitch is that when you multiply or divide both sides of an inequality by a negative number, you have to switch the direction of the inequality sign. Okay? So let's go to the book. Page 500, we'll do one of these together and then on each page, and then you will do one on your own. Okay? So we're going to start on page 500, guided practice, problem number 1. If you do not have your book, then write this problem on the piece of paper that you are going to follow along with in class. 6 plus h is greater than or equal to 12. A separate piece of paper. Who doesn't have their book? That I need to mark as just Alicia, who left hers on the bus. Do you have a piece of paper, Alicia? Yeah. Okay, good. All right, and does anyone not have a pencil that I have to mark as unprepared? Yes?
Does the pen only count as being prepared?
You're fine. You should have a pencil, but that's okay. As long as you can write notes and do problems in class, right? Okay, so solving, this is a one-step inequality, just like a one-step equation. And the reason it's called one step is because there's only one thing you have to do to get the variable all by itself. So it's just like solving the equation. So what is the one thing that I have to do to get the variable by itself on this problem? What is my one-step Roman?
You write 6 plus the negative.
Okay, so you have to get rid of this 6. You want this to go to 0. So Roman said write plus negative 6. Which some people write plus negative 6, or other people just write minus 6. Either way is fine, okay? And if you do it to one side, you have to do it to the other side. That's good algebra, right? So you subtract 6 from this side, it makes 6 minus 6 is 0, so that's gone, leaving you with just h on this side of the equation. And over here, 12 minus 6 is 6. So h is less than or greater than or equal to 6. A one-step inequality. Undo, if this was a subtraction, you would undo it by adding 6. It was like h minus 6, right? We don't do checks on inequalities, but we do often graph them on a number line. So to graph this solution, I want the number line to cover up all of the numbers that make this inequality true. That would be any number bigger than 6 or equal to 6. So my number line is going to have a circle or a dot at 6. And then, is that circle going to be open or closed? Alicia. Open. And why do you say that? So the thing to decide whether it's open or closed is you have to look at this symbol. If it includes the equal sign, that means that 6 itself makes this true. 6 is greater than or equal to 6. So if it includes the equal sign, then the circle is filled in, closed, to show that 6 itself is part of the solution. Okay, so this number line, you don't have to write all the numbers in, you can just write 6. Closed circle, right? Closed because it's each greater than or equal to. If it was just greater than and didn't include the equal to part, then this circle is open because 6 itself does not make this true. 6.1 would make it true, but not 6, because 6 is not greater than 6 if there was no equal to part in the symbol, right? Like what you're going to do on this one when you do this one by yourself. All right, so that's the first type of problem. Adding or subtracting to undo subtraction or addition. All right, jump over to page 508 now. We'll do one of these problems together, and then you'll do those two on your own. Okay? All right, so I'm going to do number 2. Actually, I think I'm going to do number 1 because it has a bad fraction in it. Okay, negative 3n is less than or equal to negative 22. This problem, in order to get the variable by itself, the variable is multiplied by a number, and to undo multiplication, I need to divide both sides. We use the inverse operation to get the variable by itself. So I divide both sides of this equation by negative 3. Negative 3n divided by negative 3. So that negative 3 divided by negative 3 equals 1, and I'm left with n by itself. Negative 22 divided by negative 3. You're like, oh, that doesn't work, Mr. Riley. That's true. The answer is a fraction. But the most important part of this problem is that in this problem, I am dividing both sides of this inequality by a negative number. If I divide both sides by a negative number, that is the glitch. That is the glitch. The thing you have to remember in solving inequalities, and that's that when you divide by a negative number, you switch the direction of the inequality symbol. It was less than or equal to, but when I divide both sides by a negative number, I have to change it to greater than or equal to. Negative 22 divided by 3, you can just leave your answer like that. It doesn't go evenly, right? So you can just leave it as 22 over 3. But to graph that, you really need to change that to a mixed number. 22 over 3 as a mixed number is, Kylie, 7 1/3. 3 goes into 22 7 times. That's 21 with 1 left over. Yes, remembering it's not so easy, but all right, what's my number line look like for this one? What does my graph look like for this number line? I'm going to start at 7 1/3. Is it going to be an open circle or closed circle? Closed circle, because the inequality symbol includes the equal to sign. That means closed circle. Okay. And is it going to go to the right or to the left? You want the arrow to cover up the numbers that make this inequality true. So the arrow is going to go to the right, covering up bigger numbers. Okay, so you could just write 7 1/3. I'm trying not to give you too many of these weird fraction ones, because we're really just trying to learn how to solve equations here. Oh, closed circle, arrow to the right. Okay, a lot like the two-step equations that we solved 2 weeks ago, except for the glitch and not having to do a check, graphing on a number line instead, that kind of thing. Okay, so two-step inequalities, page 514. Page 514. Page 514, Chad. Page 514. Two-step inequalities, just like two-step equations, have two operations that you have to undo. And remember, you have to undo the addition or subtraction first, and then you undo the multiplication or division. So, solve 3x plus 4 greater than or equal to 16 is example 1. So some people will want to use the little bubble here to remember that you can't do this division first. First, you have to get this by itself. You get rid of this plus 4 by subtracting 4 from both sides. Then you're left with 3x is greater than or equal to 12. And just like we did with equations, a vertical line here is where all your greater than, where all your inequality symbols should be there. That's the balance point of your inequality. So now I can undo the multiplication here, just like a one-step multiplication equation, by dividing both sides by 3. 3 divided by 3 is 1. That leaves me with x and 12 divided by 3 is 4. So x is greater than or equal to 4 is my answer. No check for these. Instead, graph it on a number line. It includes the equal to sign, so it's a closed-in circle. And I want the values that are bigger than 4 to get covered up. So my arrow goes to the right. Number 2 is basically the same problem, except for the number is in front of the variable in this one, but it's still added on, so we still subtract from both sides and then divide. Okay, so that one's not that much different than example 1. Okay, so the got it letter A here, I'm going to show you how my work looks on these rather than having the book do its thing. So I would suggest that you write this example problem out, maybe on the green space to the left or right, whichever page you're on. I'll write it off to the side here too, okay? So, well, I'll write it down here. So the problem is 2x plus 8 greater than 24. My first step, undo addition or subtraction. Cannot touch this until it's by itself. So, and I'll draw my line here to keep my balance point. And I subtract 8 from both sides to undo this plus 8. That's an equals bar, right? Because I'm adding or I'm subtracting 8 on this side and I'm subtracting 8 on this side, leaving me with 2x over here is greater than 16 over here. Then, is Ben singing back there? Or is it Marcus? One of you's humming back there. Okay. You? All right. You were distracting me. To undo this multiplication, I divide both sides by 2. We show division with a fraction bar, not with an elementary school division symbol. 2 divided by 2 is 1, leaving me with just x. It's not negative, so I don't have to flip the inequality sign. If it was negative, I would have to flip it, but I don't. And 16 divided by 2 is 8. So x is greater than 8. What is my number line going to look like for this problem? Open circle at 8, and arrow going to the right. So I do 8, open circle, and arrow to the right. That's how I show it on my number line. To make sure that your colored in part doesn't just look like the basic number line if you have to draw it in there. Okay. Open circle because there's no equal to, and covering up numbers that make this true, which are the numbers that are bigger than 8. Okay? Solving a two-step inequality. All right, now the next example is a challenging problem. Okay? People get this problem wrong at every level. Because when they look at it, 7 minus 2x greater than 11, they think that because there's subtraction here, they have to add 7 to both sides. And that is incorrect. That is not what you do. Okay? Yes, James. Nope, you don't divide either. I have to get rid of this 7, okay, because it's added on here to the variable, but it's not being subtracted. The variable is actually being subtracted from the 7. Weird. I call this a twisted equation when they look like this. A subtraction before the variable. When you have subtraction before the variable, you need to switch it. You need to change it to addition. Minus 2x is the same as plus negative 2x. Over here, you might want to just do plus negative 2x. And if you do that, then it's more obvious that this 7 is actually being added to the variable. And so I have to subtract 7 from both sides. Not only that, but this minus sign now is on the 2. So when you do the subtraction of 7 from both sides, and this goes to 0, you're left with negative 2x is greater than 4. Some people will drop this minus sign off. Okay, negative 2x greater than 4. Now, undo the multiplication of negative 2 by dividing by negative 2, and now I got a glitch because I'm dividing by negative 2, so the inequality sign flips direction because I divided both sides by a negative number. And my final answer is x is less than negative 2. My number line graph, an open circle, because there's no equal to sign, and the arrow going to the left. We don't do checks, although you could in your head if you wanted to. Okay, checks are not required for those. The last example here, a division problem, a two-step equation with a division in it, right? X divided by 2 instead of something times x. Same thing, we bubble this division, undo the subtraction first by adding to both sides. Then undo this division by multiplying. Okay, so x divided by 2 here, I need to get x by itself. I do that by multiplying both sides by 2. It's not negative, so I don't have to flip the sign. X is less than negative 6. And again, open circle because there's no equal to, and arrow to the left. Okay, so